All right, so we're looking at acceleration. Acceleration, this is in section 1.4 of your textbook. Acceleration is right here. It's the rate of change of velocity. And there's a couple things that we need to mention with acceleration. First, let's start with a formula, because everybody loves a good formula. We know acceleration is, if it's the rate of change of velocity, what that means is how velocity changes over time. So we're just dividing the change in velocity by the change in time. Or sometimes you will see it as, anytime it's delta anything, you'll see this as well. Acceleration is v2 minus v1. That's really what delta means. When I say right here delta v, that delta means change, right? V final minus v initial. You could argue the same thing over here. Delta t, most often you'll just see it as delta t. So this is sort of typically what we'll see. But you could also write delta t on the bottom here as t2 minus t1. So you'll see v2 minus v1 divided by t2 minus t1, which, if that reminds you of a slope, that's because it is. And we'll talk more about that later. But acceleration then, v2 minus v1 over delta t. Couple notes then that we can say about acceleration. One, and it should be a tip off here by the arrows I'm putting on it, acceleration is a vector. That means it has both magnitude and direction. Okay, so when we write acceleration, we'll see it with that arrow on top. This thing is a vector. Second thing, if you think of the units on the top, so if you look at the top here, velocity is measured in meters per second, at least that's the base unit, and time is measured in seconds. So if you're thinking about units, the units are meters per second squared. And that sometimes seems like a funny unit. Just remember, if I have the formula, if I say acceleration is equal to v2 minus v1 over delta t, if you're thinking just units, so over here let's say units, if I'm thinking just units, on top I've got meters per second, and on the bottom I've got seconds. Meters per second is a funny unit as well. But if I put seconds on the bottom here, that's kind of like seconds over 1. What I'm doing here is I'm dividing fractions. So meters per second, that's really the same as meters per second times 1 over seconds. So just remember, if I'm dividing by a fraction, that's the same as multiplying by the reciprocal of the fraction. And if I can say meters times 1 on the top, that is meters, and seconds times seconds on the bottom, that is seconds squared. There it is, meters per second squared. Meters per second squared is meters per second, like we've got over here. So that's a quick run through of the units, but the units are meters per second squared. We can also say, so I'll move over a little here, we can also say there is an acceleration if either speed changes or direction changes, because remember, acceleration is the rate of change of velocity, and velocity has both magnitude and direction. So if either of those things changes, I've accelerated. So you could say there is a change I should say if, I guess. If there's a change, let's see if I can do this right. Get rid of my 3 here, we'll get rid of that. And I'll say here, if, and we'll see if I can sneak a little 3 under here. If there's a change in speed or direction, there was an acceleration. Something that we'll talk about a lot is constant acceleration. And constant acceleration, I don't know why I always like to underline these things, but constant acceleration says that velocity changes by equal amounts over equal times. So, for example, let's say if my acceleration is 5 meters per second squared. If my acceleration is 5 meters per second squared, what I could say then is, if I was to build a little time versus velocity chart, and I shouldn't say delta in there, I guess I should just say velocity. There we go. If this thing is measured in meters per second and this thing is measured in seconds, time is measured in seconds. If my acceleration, this is over here is an acceleration. Acceleration is 5 meters per second squared. If my acceleration is 5 meters per second squared, then I would say, let's say at time 0, if my velocity is 0, then after 1 second, I am going 5 meters per second. Because remember what acceleration means. If I say acceleration is 5 meters per second squared, that is 5 meters per second per second. So again, we're coming back to that weird unit. Meters per second means for every, let's see if I can change my color here, for every 1 second that goes by, my speed increases by 5 meters per second. So it goes up by 5 meters per second every 1 second that passes. So if that's true, then after 2 seconds, I'm again going to add 5 meters per second, but I was already at 5 meters per second, so now I go up to 10. So what we're doing here is adding another 5 meters per second to the speed. We can keep that pattern going. So after 3 seconds, I add another 5 meters per second. Now I'm going 15. And after 4 seconds, I add another one, and I'm up to 20 meters per second. And so on. That just keeps going, dot, 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 on both sides. This thing over here, this thing right here, this amount of speed that I'm adding every second, that's my acceleration. So that thing right there is acceleration. And again, what we're saying then is the acceleration is 5 meters per second per second. For every 1 second that goes by, my speed increases by 5 meters per second. So in this problem here, we've got Shanjeeth throwing a dodgeball at John at 18 meters per second east. It misses John, it hits the wall, bounces back 0.25 seconds later, going 14 meters per second west. And we're going to find its average acceleration. So I'll start off just listing some stuff that we know. We know V1 is 18 meters per second east. What else? We know time. That's this thing right over here. We know time 0.25 seconds. And we know V2 as well, because we know it bounces back. It bounces back going 14 meters per second, and it's going in the opposite direction. And just watching questions like this, sometimes they won't give a direction for this one. They'll just say it bounces back 14 meters per second. If it's bouncing back, that's kind of enough information right there for us to figure out that it's going west. Here it's given, but just watch for that in some questions as well. So there's my givens. My unknown, I'm looking for average acceleration. Here's acceleration, it's question mark. We should pick a positive direction. And you're welcome to choose either east or west as positive. I'm going to choose west as my positive direction. If you want to do east, you go ahead. We should get the same answer. I'm going to choose west just because I know that my final direction is west, and sometimes that's nice. So I'll go ahead. I'm going to use, here's my equation, acceleration, v2 minus v1 over delta t. We know acceleration, I'm going to sub in v2, and just keep in mind in this equation, it's v2 minus v1. It's not big number minus small number. Sometimes people do that. It is v2 minus v1, okay? So this is v2. That number's got to come first. It's 14. Let's also just double check the direction. It's 14 west, and over here I said west was positive. Okay, so this number goes in as a positive. Subtract v1. v1 is 18, but also keep in mind that it's 18 east. And again, over here we said west was positive. That means east is negative. This number goes in as a negative. Okay, so it's positive 14. The minus sign here is part of the formula. The minus sign here is because of this direction. So 14 minus negative 18 over time. Time is a scalar. We don't have to worry about directions or any negative signs there. let's see, minus 14 plus 18 really is 32 over 0.25. And we divide that, we get acceleration is 128 meters per second squared. That answer is in my positive direction west. And for significant digits, we should go ahead and round this thing. You could say 130. I'll say 1.3 times 10 to the 2 meters per second squared, and that is west. So there's sig digs and direction. Don't forget direction. And that's it.